for every specialty, you need to understand how to resolve any kind of doubts or argument. And in every domain, there are certain authorities, experts, who say that until something happens, these are my gurus. So these kinds of things all go into factual knowledge. Like we say that algorithms, you have a doubt, if Nuth says something, that is the last word. Okay? There cannot be any question on that. So like that, there are kind of references. This all goes into factual knowledge. Then conceptual knowledge essentially refers to what is a basic concept and what are the things which are involved in these concepts, related set of facts. And many people find that people are very weak with concepts. Now why I am saying is, how do you make a student understand a concept is quite different from how do you make the student remember a fact. Your instructional strategy has to differ based upon whether it is a conceptual knowledge or a factual knowledge. A factual knowledge can be repeated, but a conceptual knowledge you repeat 100 times, it's not going to help. Conceptual knowledge requires a different kind of instructional strategy. So the type of knowledge, the category of knowledge has an important bearing on how the instruction is to be organized. So concepts can be many, like we have force, stress, strain, electrical field, magnetic field, a vector, time complexity. These are all concepts which we need to understand, and these concepts have to be taught in a particular fashion, and that requires an amount of original thinking from the teacher's mind also. And many of the textbooks are not all that good when it comes to teaching a particular concept for a classroom. They just define it and leave it. So that's where your creativity can come in. Then we have procedural knowledge, which essentially refers to a sequence of steps that can be employed to solve a particular problem. But this is just not that much. It can also mean if there are multiple procedures available, which one is the best one for a given scenario? For a particular kind of a context, which one should we apply? How do you use that kind of a discrimination? And how do you figure out that this is the best procedure to be applied in this context? So that is procedural knowledge. Because as you know, it's only in university examinations that we ask the question, start the following using IPSA. In real life, no one will tell you use IPSA. In real life, you have a problem to be solved. Which technique you want to adopt, you have to figure out based on various constraints. Okay, so that knowledge is also part of the procedural knowledge. Then before going into engineer specific knowledge, the metacognitive knowledge is something about self, something about your own strengths, your own weaknesses, what is it that you know well, what is it that you do not know well. And half the time, if I know that I do not know that I know something, then I can spend additional effort to acquire that competency. If I even do not know that I do not know a particular kind of concept, then I wouldn't be putting any extra effort. And I wouldn't be aware that actually I am deficient there. I would be happily going along thinking that I am expert in that also, but actually it turns out that I am very poor there. Many of the times the students suffer from this kind of a problem. And as a teacher, you must help the students understand themselves. They must realize where they are weak. If I know, for example, that I am poor in drawing, and I am doing a course in machine design where I have to cut out drawings of machines. If I know that I am poor in drawing, I am going to spend extra hours to pick up that skill. I am going to go to a friend like him and ask him, can you explain, give me a tip on how to draw this, I am not able to get it. So I put all kinds of efforts to improve the skill in that area because I know I am deficient. If I do not even know that, then there is a question of my improving myself. So some kind of Atmajnana is required for people to improve. Only when I know somewhere I am deficient, I will try to improve. So that is about metacognitive. Very simplified, I am saying it's not all that simple, but I am just trying to give an overall picture. Then if you look at engineering knowledge, fundamental design principles, every domain has certain basic design principles which you must understand. Like for example, any device which has two states can serve as a memory element. That is basic design principle. So whether it is a transistor as a switch, or whether it is a fluidic element as a switch, or whether it is some other kind of a component, I know that it can serve as a memory unit. That is the basic design principle. Then every engineering domain has importance of criteria and specification. How do you specify something? What are the dimensional units? What are the typical units? Dr. Babu would know that in many times in interviews, even computer science faculty, when they are asked to give the specifications for a laptop, half the time they are stumbling. Even Professor is laughing. So, you know, because specifications have not received the kind of importance that really they deserve in engineering. All engineering is based on numbers. Without criteria and specifications, there cannot be any engineering. The first thing you do when you are designing a product is specify. But we do not give enough importance to that during the course, any course that we teach. So that is an important kind of a knowledge that one must acquire, and one must have a sense of numbers also. Some kind of a feel for numbers in every engineer must have, related to their domain. Like somewhere, if I am saying that I am sorting 1 million records on a desktop, typical today's desktop, let us say based on whatever it is, 4.7 or 4.5, whatever it is, I must have some sense of how much time it takes. I can be off by 30% it doesn't matter, but I should not be saying that I simply don't know. Similarly, if I got a beam of this much length and on the middle if you place an apple, what would be the deflection of this beam? A mechanical engineer must have, civil engineer must have some sense, some very good sense of the numbers. So these all goes into the dimensions of criteria and specification. Some feel for these things, because in engineering ultimately has some sense of feel also to the designs. Then there is a question of practical constraints. When you are trying to design, there will be some practical constraints like where do you place an indicator lamp, or where do you place a switch, when do you use a countersunk screw, when do you use a flush screw. So there are some practical constraints which one must understand when it goes to design. So there is that kind of a knowledge. Then finally, design instrumentalities, some concepts like a top-down design or a bottom-up design or some kind of a design walkthrough. People have certain kind of instrumentalities developed over a period of time. They must know that. I leave it at that. Then if you look at the cognitive process, remember is the lowest level. Remember can mean actually both recognize and recall. That means shown something, I am able to recognize what it is. Shown a figure of 4 figures, I can say which of the figures corresponds to an AND gate. It can also mean recall. Given a keyword, I can recall whatever is the required thing. Like for example, given a keyword, what is superposition theorem, I am able to say what it is. So it can be that. It is the lowest level but important. Every time I cannot keep referring to an internet or some reference book for every small thing. Certain things they must become internalized. Anytime you ask me, I must be able to read out those definitions, those concepts, like that. Otherwise it becomes highly inefficient. A good engineer must know these things which are relevant to his or her domain. So certain kind of remember knowledge is essential, and it's not that remember is bad, but if all that we are trying to promote is only this, then we are somewhere falling short of the required kind of capability. The second level is understand, where essentially the student is able to do several things which are related to understand. And what are those things would mean I am able to interpret something given in one language, I can put it into another language, or given an example, I can say to which category that belongs, or given a conceptual category, I can give to the examples belonging to that category. For example, can you give one example from everyday life of highly viscous fluids? If you are able to give that, that means you have the understanding of the concept of what is viscosity and what is a viscous fluid, what is a highly viscous fluid. If faculty I am assuming is from different domains, right? Civil, mechanical, all these domains. It's just not computers or electronics. So, like that, you should be able to do. That demonstrates understanding. And of course, if the instructional context is same as assessment context, that means whatever I tell in the classroom, I ask the same thing in the examination also. Then instead of at the level of understanding, it may cater down to only the level of remember. In the sense that in the classroom I explain something about viscosity, highly viscous fluids, and from a daily life I give an example of a highly viscous fluid, and in the exam simply I ask, give one example of highly viscous fluid from daily life, and the student without understanding what is viscosity, what is viscous fluid, highly viscous fluid, only remembers that in the classroom I have given that example, so reproduces the same example. So it doesn't show understanding, it only shows remember. How do we eliminate this? Like I was doing a teaching course in software engineering, there is a concept called emergent properties, and in the textbook by Somerville, he gives an example of a bicycle as a case study of emergent properties. When you take a wheel, pedal, brake by itself, they have certain usefulness, certain properties. But when you assemble all of these together, it becomes a means for transport, which is an emergent property. So we say systems have emergent properties, like reliability, which comes in only when you put everything together. Now, in the exam, if I ask, what is an emergent property, give an example. If there are 18 MTech students, all the 18 MTech students will give only bicycle as an example. And if I ask why play tricks are, it's safe, it's there in the textbooks, I know that I get full marks if I give a bicycle. Otherwise, I don't know whether you will give me full marks or not. That means they are not confident. They are not confident about the teacher. They are not confident about the concept also. Even they are not confident about the teacher also. Now, how do we eliminate this? Is looking remember. So, when you assess, you must ensure that it doesn't fit down to remember. How do you do that? I leave to you all these things. But you reflect on all this when you get time. Okay? Then apply essentially is from a low end to a very high end, from a well-defined procedure, the way it is taught in the classroom, exactly the same thing I do in the examination assessment also. Only thing is there it was number 4, it is number 6. Other than that, it is all same. So it can be such a mechanical way of applying a known procedure in a known context with only changing the numbers, to highly creative activity where an unknown context, a combination of the known techniques need to be applied. You need to figure out how to do that. So the apply can be a very mechanical, routine activity to highly sophisticated creative activity over a spectrum. Now, where you place your particular outcome is up to you, but it's a fairly big spectrum that we have here. Then analyze in engineering normally the way Bloom meant it we don't do, but engineers typically have been using the word analyze essentially to mean something else. Electrical circuit analysis by Rajanikanth is a very famous textbook, but actually what you do inside is not really analyze. What you have is a procedure. You apply that procedure, you get the values. You have an electrical circuit, there is a procedure for forming the loops, there is a procedure for writing the Kirchhoff's closed loop equation, there is a procedure for solving a set of differential equations. You do that, you get currents and voltages. Where is analysis here? But we call it as analysis because traditionally that has been the name used. But for Bloom, analysis means that within the context of an overall system, you are able to figure out the role played by a subsystem. And you are able to see what is the impact of changing this subsystem on the overall system. If I take one module, if I change its input-output specifications in a complex software system, what will be the impact? What would be the impact on the interfaces? What would be the impact on reliability? What would be the impact on module complexity? This kind of a thing I am able to figure out. So, in the context of a system, if you are able to analyze the component, or if you are able to figure out a viewpoint, that becomes analysis according to Bloom. Generally, in Bloom's taxonomy, this is one controversial word. In engineering, we use it in a slightly different sense. Actually, according to Bloom, what we do in engineering is apply procedural knowledge rather than analyze. Then evaluate is a slightly higher level cognitive activity which requires some kind of a judgment or critiquing based on certain objective criteria and standards. Every time we are judging whether this is good, that is bad, this talk is good, this talk is bad, this lecture is good, that lecture is bad. But if we can do this based on certain criteria, specifications which are objective, then it becomes evaluate. That means based on certain standards of consistency or certain external defined standards, if we can do a critiquing, that becomes the evaluate. Then the highest stage, of course, create, where something new emerges from the student, which obviously means that in a limited time exam we cannot ask, but in a mini project, in a main project, in a term paper, in a design paper, you can ask. But a truly design activity has two aspects. One is a divergent phase where you come out with multiple solutions to the problem. Then a phase where you do evaluate and figure out which is the correct, better solution. Then a convergence phase where you get into one particular approach and then implement it. So unless really there is a divergence, convergence, there is no creativity. If there is only one way of doing it, then it becomes applied. Only when there are multiple ways and you come out with those and then creatively figure out which is the correct way or better way or improved way, choose that and then implement and then give a justification for all this, then it becomes a creative kind of an activity. So sometimes projects really are not creative. On the web you see an algorithm, just implement it and produce it. So there is no creativity, it's only apply. But it's the highest level of activity and the students, if they get some feel for it, then you have given them a taste for what engineering is. So that would be the highest level. Typically in engineering, the lower 3 levels, if you can do well, that is enough. But it would be a good, interesting exercise to look into some of the university papers and look at the questions and tag them and see at what level they are. Maybe look at your own question papers, tag them at what level they are. Then see the corresponding COs and see at what level they are. Or look at your instructional activities and can you characterize which level is facilitated by that kind of instruction. These kinds of discussions, analysis, some kind of group discussions if you can do, that would be an interesting kind of an exercise for you to figure out ways of coming out with an improved way of teaching, an improved way of assessment, consequently an improved way of accomplishing the required outcomes from the students. Because ultimately, as I said, they are interested in all the 3 aspects. The outcomes, which are the statements of the student, competencies that we are planning for, the instruction design, how we facilitate acquiring of those competencies, then assessment, how do we assess to what extent these have been assigned. So if you can create a kind of what is called as a taxonomy table like this, and if you can place your COs, your instructional activities and your assessment items into this table, if they all are in the same cell, then the most ideal scenario. And one across the table in one cell, completely disparate, that is a very undesirable kind of a scenario. That is a CO in some corner here, an instructional activity in some corner there, an assessment item in some corner here. That would mean that the learning is really not being facilitated well by us. So basically the taxonomy is the mechanism by which we can ensure that we take the COs in the proper constructive spirit, we plan the instructional activities to facilitate the acquiring of the COs. So no, please do not look at the lesson plan as simply saying in this hour I cover this topic. You look at the whole scenario, the total course, look at the entire set of outcomes. Then you try to visualize what experiences do I provide to my students to ensure that they acquire these competencies well. So that is how you should look at it, and that actually should be your lesson plan. That in this class, this is what I will be doing, these will be my kind of instructional activities, and these are the experiences students will have, and this is designed to facilitate acquiring of these outcomes. So that is how you should look at the entire instructional activity. Then assessment also you plan upfront, right in the beginning, the first day before you go to the first class. What will be your assessment instruments, IO tests or quizzes or whatever are permitted, alternative assessment mechanisms, sub-learning, whatever you have. What will be your assessment instrument, each instrument, how it is designed, which COs are going to be tested, and if a CO is at one particular level, how many questions will be at that level? Some questions you may wish to deliberately ask at a lower level. A CO might be at apply level, but you might wish to ask 1 or 2 questions even at remember level. It's up to you. You plan. But do all this planning upfront and share it with the student and tell them this is how you are going to be assessed. And when the students know upfront what is it expected of them and how they are going to be assessed, generally learning is bound to improve. It has been established empirically. So look at this entire gamut of activities in a slightly broader and more systematic perspective, and a taxonomy would really help you to do all this well. There is one more slide on one more PPT on course outcomes, but I will not touch it here. But when you have time, just go through that. There are certain exercises at the end. Don't look at the answers. They are available to you anytime to see. But for each question, reflect, do some discussion, And then after that you can see my comments which are following. So that would help you. And for this you can set up small groups in your own department, small interest groups. And now already you have committed to sir that it is going to be more than 3 hours a week. So you will have more time. Formal interaction may be only for 3 hours, but you will have more time spent on these kind of things. So you can plan some kind of interest groups where you do these kinds of discussions and come out with your own ideas. And anytime you find some interesting kind of novel way of doing things, please do share it with your principal, with your deans, with your heads. And if something is working well in the class, please do share it with me also. And it would be a nice way of promoting good learning, deep learning, which is what, as good teachers, all of us should be concerned with. So let us learn from each other and try to make learning something which really is of high quality for the students. So I think this is a place I should stop. If there are any questions, please feel free to ask.
Devraj from mechanical department.
Yeah.
So usually there is a misunderstanding with respect to the action verbs when you're using the Bloom's taxonomy.
Yeah.
Say for example, I'm using a word determine.
Okay.
So it is simply an understanding level of question. Determine a particular thing, whether A is equal to B plus.
Yeah.
But same thing, like if I ask at the higher level,
Yeah.
so maybe the determine word is there at the second level as well as the third level, as well as I can take it to the fourth level. So the misunderstanding is if I use this word determine, it is assumed to be like it's at fourth level. So how you can tell that that word is not the right thing of determine at what level of group taxonomy?
Excellent. What our friend has asked is very good question. That many times to help the faculty write these outcomes, people are given a list of action verbs, saying that these verbs belong to these categories. But please note that there is only a kind of a help, a guideline. It's not to be applied mechanically, in the sense that the moment I see a word compare and I see that it is under the category understand, don't jump to the conclusion that it is at understand level at all. Same word compare occurs at analyze level also.
Yeah.
So do not go blindly by trying to look at a verb and then trying to infer mechanically that it belongs to certain kind of an action verb category or knowledge category or cognitive process category. Never apply these rules blindly. Instead, try to really look at the outcome, what activity the students are doing, what competency the student is acquiring. Based on the kind of competency that the student is demonstrating, you have to see whether it is at understand level or whether it is apply level or whether it is analyze level. Like if what the student is able to do is compare two entities within the context of an overall system and explain how in the context of that system, this subsystem is comparing with this subsystem, then this becomes which level? Analyze level. On the other hand, if there is no surrounding context, two items are being compared on their own work without any surrounding context giving any limitation to that, then it becomes only understand level. Similarly, if you are computing, if it is only a particular formula that needs to be understood, values need to be plugged and you need to compute a value, then it is basically understand. Like if I know that a parallel plate capacitance is given, the capacitance is equal to A epsilon by T, where A is the area of the parallel plate and epsilon is the dielectric strength of the material inside and T is the plate separation. And if I give you area, epsilon and T and ask you to find the C, it is determined, compute only. But it's not a procedure, it's only an understanding which shows how the capacitance is computed. On the other hand, if I say compute the dominant root of the following matrix, dominant eigenvalue of the following matrix, using a particular method, like power method, then it becomes a procedure. Because we know that power method has certain steps, 1, 2, 3, 4, which need to be followed and they need to be iterated. So there is a particular procedure to be followed, so it is an apply a procedure. So here if I use the word determine, it is apply a procedure. So never determine these kinds of things like determine based in a mechanical fashion. Look at what the student is demonstrating, what is the competency, what is the outcome, what is the process which is involved. Then based on that, you figure out to which cognitive process level it belongs. So that's the issue. Which means that actually one should spend certain time going through these cognitive process categories and then discuss them, and then when a particular assessment item is there, apply your mind creatively to that and then see what is the category. It's not a mechanical activity, certainly. Good question, sir. Anything else? Yeah, please.
We've got to know through various trainings on this topic that a course can be mapped on all the cognitive processes. It's not necessary that a course should be remember, understand. We have understood that
CO, not course.
Course outcomes should be educated.
Yeah. So don't say course outcome.
Course outcomes.
CO.
Yes,
Yeah.
The CO should be educated to apply, analyze, and all our evaluations or assessments should rise to that level. But do you also think under the knowledge categories we should touch upon all the criteria that's been listed? Is it possible or?
Yeah, I understand what you are saying. My submission is that neither cognitive process nor knowledge category can be simply coerced and twisted into a course. It basically depends upon the nature of the course that you have got and the time that you are having. And based on that, certain things would look feasible to you, certain things would not look. You should try to move up, there is no doubt. But certain courses, practically it makes no sense to go to analyze level or create level. Okay. Like for example, modern management theory. There is hardly anything to do even at apply level. 90% of it is at understand level, and it's enough. If you do that, that's enough. So the course content would dictate to what extent a particular kind of cognitive level is suitable. But as a general guideline, try to provide higher level of cognitive process verbs because they are concerned with deep learning, they are concerned with higher orders of learning. But again, don't go by a mechanical guideline that every course must touch at least analyze level. You may not be able to do. So do some kind of brainstorming. The concerned faculty, 2-3 people at least who have taught the subject, let them sit together and do it. Similarly, when you come into the knowledge categories, make some conscious effort to bring in different categories. But for that sake, don't make the course artificial and tedious. Ultimately, don't artificially try to coerce things into that. If it naturally fits into that, if you are able to achieve that kind of natural integration, good. Otherwise, leave it for the next level. But I would suggest that certainly criteria and specifications, design principles, wherever they naturally fit in, put proper emphasis. Put proper emphasis. Like if you are teaching a course on computer organization, certainly specifications play a natural role. So give certain emphasis to that. On the other hand, if you are doing a course on internals of operating system, the specifications may not play such a big role, but the design principles will play a big role. So emphasize that. If you are doing, let us say, some other course like control systems, then criteria and specifications, to some extent, yes, they play a role. Design principles, certainly they play a role to some extent, but design instrumentalities may not play a big role. You teach a course like software engineering, design instrumentalities play a very big role. So, where they naturally fit into the content, try to give an emphasis to that consciously and try to tell the students this is the kind of a knowledge that is involved in this and you must pick up this kind of a knowledge. So which also means that we should be conscious. Like for example, almost all of us do teach digital electronics. We teach them 74 LLS 00, 74 ALS 00. Right? Our electronics faculty, they would know. But not even one student, and many times in faculty really do not know what is meant by ALS, what is meant by LS, why those terms are used like this, what does it mean to say it is 7400, on the other hand 74 LS 00, 74 ALS 00, what do they mean? What do they mean in terms of the specifications? Do they have something to do with the absolute temperature at which you can operate the AC? Do they have something to do with the absolute DC voltage at which you can operate? Is there a relationship or there rule? Because actually that's part where you can put, you could have put something about specifications. But your textbook doesn't talk, so we also don't talk. So what I'm saying is whatever fits in naturally into the sequence of topics you bring in. Artificially don't bring. Yes. the extent possible, go to higher levels of cognitive, go to other categories. But for that sake, don't twist and torture the subject and the students. Yes. Yes. Yeah.
My question is, how to encourage students to develop critical thinking skills and
Problem solving skills. Actually, in the slide it is there. I didn't spend time on that. Actually, if you Meanwhile, you please think what is critical thinking? Yeah, please, sir. What is critical thinking? So I had slides, but I didn't go through because, in fact, even your problem solving slide is also there after this. I didn't go through because time. But what do you think is really critical thinking?
students should understand the concept.
Understand is different.
Yeah, just go to the depth of the concept and try to
Still understand.
come out with something else. Which is
What is it? In fact, I would like to again appeal to all of you. There are certain words which we use quite frequently with lot of reverence and respect. The students must be good with basic concepts. Every person from industry says this, every person from HR says this, most of the faculty also say this. Now, what is the concept?
Right, the student is able to analyze things.
Analyze is different.
No,
I am
that's the
asking
beginning
what is
of-
the concept?
That will be the beginning of critical thinking. Then we can go a little-
Critical thinking you are coming. So critical thinking essentially would be understand, analyze, what else?
investigate,
Investigate is nothing but analyze.
maybe evaluation kind
think
of.
from such principles and able to criticize what is the idea.
That is nothing but evaluate, critique.
Yes, but able to tell what is the limitation with that.
Agreed. That is part of critique. Critiquing is essentially that.
Make a decision on which what to do.
Agreed. So that is if you are looking at the final part of the create. So if you see really, there is nothing beyond understand, apply, analyze, evaluate, which is involved in critical thinking. If you are able to do this, then you are able to engage in critical thinking. So what essentially we have after a fair amount of thinking we have seen is that words like critical thinking, problem solving really do not mean anything beyond these categories. Only thing is certain people wish to have a different name. So there is also a website called criticalthinking.org. Now you go to that website, go through any amount of hours, you will not see any basic cognitive process beyond this again. You can use words, but essentially what competency you are looking at, if you see, as you yourself just now mentioned, it is understand well, deeply, true. Then you are able to analyze, you are able to critique based on certain kind of standards that you have got. And then you are also able to, based on that, give a judgment. Say that yes, this is okay, that's not okay. So that's also part of actually evaluate, give a judgment. So judge. In fact, if you see one of the verbs for that evaluate is judge. So if you see one of the verbs judge. Okay. So basically, the so-called critical thinking and problem solving are essentially skills and the cognitive abilities which are stitched together from these processes only. So if you are able to take care of these processes, you are able to take care of that.
In my assessment pattern, I have I've taught everything in the class. I've made students analyze, I've made students evaluate, I've given the same kind of questions in the test also. But still I end up seeing students who can't critically or who can't apply.
Yeah, so what do you infer? As a teacher, you should really do this, no? Closing the cycle. So as a teacher, now what is your own inference from this data?
Sir, maybe the critical thinking will mature with time. Maybe first time when I'm learning this subject, I won't be able to think. Maybe after a couple of times I go through it, maybe at the end of the course, I'll be in a...
But you want the students to go through 2-3 times even after getting S grade?
So not like that. Maybe at the end of the course, I'll be in a position to understand the particular topic.
Correct, but at the end of the course is over, no? What he is saying is at the end of the course only no critical thinking. Obviously, for that sake, you can't tell the students enroll again.
The number of times he is going to the topic, not like examining.
So, what you are trying to say is that can thinking occur at multiple levels, in multiple courses. But if that is to be done, you are not teaching the next course. So, what do you do?
Change the way that we teach.
So, I would like you, sir, you as a teacher, you have taught a course, and in your own words, you have done everything that is possible. You have done taught well, you have given all the cognitive levels, you have made them do all that, but still you are not happy with the students' performance at the critical thinking level. So, what is your encouragement?
Critical thinking in the sense I'm just looking out of the curriculum.
No, you please be clear. You want them to have critical thinking ability or not? Don't say critical thinking outside the curriculum, critical thinking inside the curriculum. Critical thinking is a capability which involves certain kind of cognitive processes. Okay. Now, if you say that if this context is same, then I will be doing it, then it's not critical thinking. It is remembering. Same thing you are able to tell. You ask me exactly for this kind of a framework, put the dots here, 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 and put a line here, put a line here. Then I will draw a rangoli. There is no creativity there. You just give 4 or 5 different kind of colors and say this much area is available to you, draw a rangoli, you draw that, then it's creative. So when you put everything and put the same context which you have used in the classroom in the assessment context, it is only a number, I am reproducing it. So please figure out what you really mean by your creative thinking capability. Then figure out what kind of instructional activities you have to design if you want to promote that. What experiences the student should get during the semester if this kind of competency is to develop. Then test it as an engineer whether doing this activity is leading to that. If not, go through a cycle, figure out what is wrong with this. As an engineer, that's how you design a product. Exactly same thing. Then next time when we meet, you give me your feedback and what is that. Okay? Or if I am not there, to you, Dr. Paul. So that's how we should do. That's how we should do. Anything else? Great. Thank you very much, and I hope that all of us collectively can make some difference to the student learning. All the very best to your young educators, and someday you should lead the next generation of students. All the best to you.